Review session 6, production costs, introduction to markets, specifically focusing on peer competition. There is a clue for another round of winning for raffles in this review session. These first 3 terms about total product, marginal, and average product, write this down. They have to do with supply side, production. They have to do with supply side of production and the product market. And it's based on inputs like labor. So per worker, what are laborers producing? So what is the firm producing per worker, I guess is the way to say it. So your total product they'll give you. Average product is taking, write the equation down. AP, average product, equals total product divided by number of workers or quantity of input. You could put QI. Marginal product is the change in total product divided by the change in input. So you would have MP over QI. And again, total product they will just give you. You'll have to know this in terms of being able to calculate what marginal product is in an AP question when they give you total product data. These are the graphs that go along with it. You can see, draw these, sketch these. On the y-axis, I would like you to put product. On the x-axis, though, put quantity of input in parentheses labor. That's what they're graphing here. You need to be very particular about the graph as in terms of where you draw the lines in the segments. You can see the first segment of the graph all the way up to the first dotted line. Marginal product is increasing. The reason is because in total product is increasing at an increasing rate. So your slope is getting steeper. So marginal product is the rate of change in total product. So if total product is changing at a faster rate, then your marginal product is going up. In the second segment, total product is continuing to go up. So marginal product, though, is going down, but it's still positive. So you're still gaining extra product with each new worker you hire, but you're not getting as much extra as you did before. What's important in the blue graph, the marginal product, it crosses the x-axis when your total product hits its max. So when you start going below the x-axis in the blue graph, it means that you're no longer getting extra product. Now the factory's so crowded, the cakes that you made are getting destroyed because they're tripping into each other. So it is hurting you to hire extra workers. So your total product actually starts going down. Now bringing the green graph into it, the only thing you really need to know about average product is that it is increasing when it is below marginal product. When it intersects marginal product, it then begins decreasing. That is significantly important. It's like the extra test grade. If your test average, the green line, is going up, then your other tests you took, blue, must be above your average. If you then have your average and tests going down on the green line, then it must be your previous test was lower than the average product. So when I say these things, rewind it, listen to it again, and point to them on the screen so you know exactly what I'm talking about. Next you have the costs. Total costs, that's how much it costs you to make a good. It includes your fixed cost. The fixed cost means the amount you have to pay without making any item of good. Cake making business, I've got to buy my stove and I have to rent the bakery store every month. So even if I don't make any product, I've made those fixed costs. Variable costs are costs that depend on how much product I make. So you should write that down. Depends on how much product I make. Cake, batter, icing. The more cakes I make, the more icing I need, the more the icing costs me. The averages, average total cost, average fixed cost, average variable cost. You just take the totals divided by the quantity of output, the number that you're making, to get those. And your graph. What you have here, you want to draw this very specifically. You need to make sure that when ATC is down sloping, MC is above or below it, much like the average test score example I gave earlier. When it intersects MC, it's ATC's minimum, and you then go up. I want you to mark something that's not on this graph. The distance between ATC and AFC, that's the AVC, the average variable cost. I need you to make a note, circle AFC, and write that it's always downward sloping because you take a fixed cost, write that down, fixed cost spread among greater output. So each time you add a new output, you're dividing that total cost by a greater number. So your average fixed cost is going to continue to go down, 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 and down. We're then going to move on to market structures. First, you're going to look over at your graph. There's no slide for this. Not your graph, I'm sorry, your chart. Looking at the chart, there are 4 structures. Perfect competition is one pole, and the complete opposite is monopoly on the right side. In between, it's like a spectrum. Monopolistic competition is more like perfect competition. Oligopoly is more like monopoly, but it's this spectrum. All 3, monopolistic competition, oligopoly, and monopoly, are all considered imperfect competition. They have the same graphs. The only difference is about barriers of entry and can they sustain profit. I would write that down. All 3 have the same graph. Difference equals how much profit they can sustain. Okay, market power over price. Competition, none. The price takers. Monopolistic competition, not much. Oligopoly, considerable. Monopoly, they are total price makers. Type of product. In pure competition, homogeneous, they're all the same, like cucumbers, the example. So all cucumbers are pretty much the same. You can't go out and buy purple and yellow ones for the most part. There are no barriers of entry in pure competition, so anyone can join the crowd, and there are many sellers. In monopolistic competition, they don't have much control over price, so they're more like competition. The difference is they have heterogeneous, also called differentiated products. That means there are variations, different size, color, shapes. Pretty easy to enter this market, so it would be like cakes. That's easy to get into cake making business. Number of sellers, considerable. Example is computers, snacks, shoes. Actually, computers is a bad example. Take that off there. Oligopoly, considerable market power. They're almost like monopoly, who has total market power. Type of product. Oligopoly, they have both heterogeneous and standardized. Unique for monopoly, strong barriers of entry for oligopoly and monopoly, blocked for monopoly. Few sellers in oligopoly, monopoly just has one seller. Example for oligopoly, automobiles, because, and write this down, where it says barriers of entry, strong barriers because of extensive economies of scale. We'll go over that here in a minute. Extensive economies of scale. Example would be automobiles. In order to make enough automobiles to be profitable, they have so much money to buy the factories and materials to make cars. It's just way harder than making cakes. Example, monopoly would be like utility, energy, and water. Okay, so real quickly, it says economies of scale. We need to draw these graphs where it says low economies and extensive economies of scale. This slide corresponds directly with the second page of your sheet. Low economies of scale. Okay, what the idea is in both. You want to be at your ATC's minimum. Write this down. Firm must be at ATC minimum to survive. Now, in the low economies of scale, mark the ATC and draw a dotted line all the way down to the x-axis. Min ATC happens at an earlier output. Cakes. I maybe only have to make 100 cakes to be at my minimum ATC. The amount of money that I need to make 100 cakes isn't too bad. Go to the right graph, the extensive economies of scale. Draw it. Right? Min ATC, greater quantity of output. Min ATC, greater quantity of output. So mark the ATC minimum down to the quantity of output. The quantity value is much higher than the previous graph, meaning for me to make one car, maybe I could hack it. But to make 100 cars, way too expensive. Can't do it. So that's one of the reasons it's hard to get into the oligopoly business. That's one of the reasons for the barriers of entry.